Three coins are tossed once. Let A denote events three heads show. B denote the events two heads and one tail show. C denote events three tails show. D denote events a head show on the first coin. Which events are mutually exclusive, simple, compound? So, first let me start by writing the sample space of the coin. So I can write the sample space of the coin is given by the formula 2 raised to the power n, where n is number of coins or the number of times it is tossed. Here it is 3, 2 raised to the power 3, which is going to be. What are the sample spaces? The sample spaces are head, head, and head. Tail, tail, tail. Head, head, tail. Tail, head, head. Head, tail, 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 head, tail, 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 head, tail, head, head. Right? Tail headed is taken. What else I have left? This and this is taken. Th is taken. Tht. So, HTH. These are the sample space of a coin when three coins are tossed at once or simultaneously. Okay. Now, A, B, C, and D are four events. Let me take what is your event A. Event A is three heads show. Event A is three heads show. This one. Head, head, head. Let me write event B. Event B is two heads and one tail show. Two heads and one tail. This is over here. H H T T H H H T H H H T T H H H T H. Next, let me consider event C. Event C is three tails show. Three tails show this one. Tail, tail, tail. Only one element. Next, D. A heads show on first coin. On the first coin, it should be head. So I can take this one, this one, this one, and this one. Four elements are there. H, 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 T, H, T, H, H, T, T. I have written down elements of event A, event B, event C, and event D. Now let me start solving the question one by one. Which events are mutually exclusive events? Two events are said to be mutually exclusive if there are no common elements between two sets or two events. I can see that in A and B, do they have any common elements? No. A intersection B is equal to a null set. They don't have any common elements. No common elements. Therefore, A and B are mutually exclusive events. Next, I can write the same thing about A and C. A intersection B, A intersection C also mutually exclusive event because A and C don't have any common elements. No common elements. Therefore, A and C are mutually exclusive events. Next, B and C. In B and C also there are no common elements. B intersection C is a null set. No common elements. Therefore, B and C are mutually exclusive events. Next, C and D. In C and D also no common elements. C intersection D is a null set. no common elements. Therefore, C and D are mutually exclusive events. Clear? Next, we can go for simple events. Simple events are events that have only one element. A has only one element H H H. C has only one element T T T. We have over here and we have over here. First two elements. Right? Only one elements are there in A and C. That is going to be your simple events. In A and C, there is only one point of data. A is H H H, T is sorry, C is T T T. Therefore, A and C are simple events. A and C are simple events. Moving on to the third one, compound events. Which are compound events? The other two, B and D. Here, B has three elements 1, 2, and 3. D has four elements 1, 2, 3, and 4. Since they have more than one element, I can tell they are compound events. Since B and D have more than one element, B and D are compound events. This is your question number 4. Moving on to question number 5. Three coins are tossed. Describe five sub questions are given. So before going to the sub question, let me start by writing the sample space. Three coins are tossed. Sample space for a coin is 2 raised to the power n, where n is the number of times the coin is tossed or the number of coins itself. 2 raised to the power 3, it is 8. Let me write down the sample space. Sample space S is going to be H, H, H. T, 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 H, H, T, H, T, 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 H, H, T, H, T, 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 H. These are the possible outcomes. S, which is going to be the sample space. Now, sub question 1. Two events which are mutually exclusive events. Mutually exclusive. Which are mutually exclusive here? Let me consider by taking, let A, the event is not given, we have to consider an event. Let A be an event of getting only heads. Let B be an event of getting only tails. A is going to be H, H, H. B is going to be T, T, T. Only heads and only tails. A and B have no common elements. Therefore, I can write mathematically A intersection B is a null set. Therefore, A and B are mutually exclusive events. I have written down one event. Similarly, you can find out the other event also. Next, three events which are mutually exclusive and exhaustive. Let me consider another event over here for the second one. Let now say C be an event of getting exactly two tails. Two tails, if you are going to get, then it is going to be HTT, TTH, and THT. Let D be an event of getting exactly two heads. D is going to be H H T H T H T H H H H H H. Oh, okay. This is not going to come, right? Only two hits, so this will not come. Yeah, here. Now, let us assume one more event of getting only one head. Let E be an event of getting only one head. Of getting only one head, you can write E. Only one head. So it is going to be uh, H H, only one head. So HTT HTH. Anything else? No. Right? Only one head. This is also not possible again. Sorry. This is on THT and TTH. TTH. Now again, you can find out if there are any common elements. Are there any common elements in C and D? No. No common elements in C and D. Therefore, C and D are mutually exclusive events. Mutually exclusive events. Then you can write mutually exhaustive events. For mutually exhaustive events, you have to consider all of them. You have to consider all of them. So I can write S will be the intersection of all of them. So union of all of them. C union D union E, which is going to be your S, the sample space itself. The sample space itself. C, D, and E are mutually exhaustive events. Mutually exhaustive events. Similarly, you can find out two events which are not mutually exclusive, two events which are mutually exclusive but not exhaustive, and so on. Let me move on to the next question, number 6. Two dice are thrown. Events A, B, and C are as follows. A, getting an even number on the first die, getting an odd number on the first die. C, getting sum of number on the die less than or equal to 5. First, let me start by writing the sample space. The sample space of the die when it is thrown two times is given by this table 1 comma 1 1 comma 2 till 6 comma 6. Let me start by writing event A. Event A is getting an even number on the first die. On the first die, I should be getting an even number. So all these numbers I can write. Here I am getting the first number which is odd. 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. Similarly, 4 comma 1, 4 comma 2, so 6 comma 1, 6 comma 2 till 6 comma 6. Basically, this particular row, and this particular row. Next, we have event B, getting an odd number on the first die. Getting odd number on the first die, I can write B as this particular row, this particular row, and this particular 1 comma 1, 3 comma 1, 5 comma 1. Here till 1 comma 6, here till 3 comma 6, here till 5 comma 6. Next, we have C, getting a sum of numbers on a dice which is less than or equal to 5. Less than or equal to 5. So let me write C, less than or equal to 5. 1 comma 1 is 2, which is less than or equal to 5. 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 not possible. Then 2 comma 1, 2 comma 2 possible, 2 comma 2 4, yes, possible. 3 comma 1 4 possible, 3 comma 2 which is 5 possible, 2 comma 3 possible. Anything else I have left? 1 comma 1, yeah, 4 comma 1 also it is possible. This is going to be event A, event B, and event C. I have written using the conditions given. Since they are talking about the two dices, I have taken the sample space for two dices. Now, coming to the questions. First one is a complement. A complement. So what is a complement? A complement is all the elements which are in S but which are not there in A. Which are not there in A. Can I tell that all the elements which are in B is not there in A? Second row, fourth row, and the sixth row are present in A, but first, third, and the fifth row are not present. These row are present in B. I can write the first question A dash will be equal to B. A dash will be equal to B. Similarly, the second one is B dash. B dash is all the elements which are not in B but they are in S. I can observe first row, third row, and fifth row are there in B. However, second, fourth, and sixth is not there. Second, fourth, and sixth is there in A. So B dash is going to be equal to A. B dash is going to be equal to A. Next, A or B. A or B. Whenever you have or, you have to consider union. Whenever you have and, you have to consider intersection. A or B, it means A union B. A and B, it means A intersection B mathematically. Writing the third one, A or B. A or B, mathematically I can write this as A union. All the elements in A, all the elements in B. If I take all the elements in A, all the elements in B, then I will be getting the sample space itself, which is going to be equal to the sample space. You can write down the sample space over here, starting with 1 comma 1 till 6 comma 6, till 6 comma 6. Next, the fourth one is A and B. Mathematically, it is A intersection B. There are no common elements in A and B. The answer is going to be a null set. The answer is going to be a null set. Moving on to the fifth one, A but not C. A but not C means all the elements which are in A but they are not in C. A minus C. A minus C. This is nothing but A but not C. This is what it means. You can write down all the elements which are in A but which are not there in C. A minus C. Let me take the next one. Sixth one is B or C. B or C. B or C mathematically can be written as B union C. Write all the elements in B, write all the elements in C. Next, the seventh one is B and C. Here I have to consider the common elements which are there in B also and C also. Which are there in B and C? 1 comma 1 and 1 comma 1. Next, I will use another ink. Yes, 1 comma 1, 1 comma 1. Next, anything else? 1 comma 2 is there. Here 1 comma 2 will be there. 1 comma 3 and 1 comma 3. 1 comma 4 and 1 comma 4 will be there. 3 comma 1 is going to be here. 3 comma 1 is here. 1 comma 4, 1 comma 4 is done. 3 comma 1 is done. Next, anything else? 3 comma 2, 3 comma 2 will be there. 2 comma 3 is not here. 2 comma 2 is not here. 4 comma 1 is also not here. You can write B intersection C as 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 3 comma 1, and we had 3 comma 2. Yes, 3 comma. Next, the eighth one is C dash, is it? No, the eighth one is A intersection B dash intersection C dash. Here I have to consider all the elements which are in A, B dash and C dash. What is B dash? B dash is all the elements which are there in S but not in B. This is going to be S minus B. C dash means S minus C. A dash means S minus. Writing the elements, you can solve the eighth sub question.